Classifying chemical reactions, otherwise known as types of chemical reactions. The first type or classification is a synthesis. Synthesis means you're producing or making something. So we could then look here and say that basically to identify that something is a synthesis, you will see that it's a compound plus a compound going to a compound, or an element plus a compound going to a compound. What you're going to see is there's only one thing after the arrow, one compound. So you're going to want to think about this as your hint there. One thing after the arrow. So triangle and circle come together as circle, triangle. The opposite of a synthesis, oh, here's an example, apologize. Example first. So we have an element plus an element. Most importantly, there's only one thing after the arrow. That's why we know this is a synthesis. The opposite of a synthesis is a decomposition. Decomposition, it breaks down. So compounds break down into two elements, a compound element or two different compounds. The hint here is that there's only one thing before the arrow. So a synthesis is one thing after, a decomp is one thing before, one chemical before. Here's an example. We have a compound breaking down into its elements. Single displacement. We're going to take some time to talk about two different kinds of single displacements. If you notice, you have an element and a compound on each side of the arrow. So you know something can be classified as a single displacement. I usually will say replacement. So you'll hear me say single replacement if there's an element and a compound on both sides of the arrow. So here's that hint to circle or think about in your notes. Okay, now we got to get a little more specific about this. We're going to talk about an anionic versus a cationic single replacement. So an anionic replacement, an anion comes from a negative ion. A cationic comes from a positive cation. A cation is a positive ion. So a cation is positive, an anion is a negative ion. Okay, so cation. So what you noticed here is that, remember that, I need to switch pen colors really quick, that this would be a plus and a minus if it was a compound, just like this would be a plus and a minus. The positive's always in the front if there's a plus and a minus. So both of these have a positive bonded to a negative known as an ionic compound. If you notice here, this guy comes in and kicks out what? It kicks out the triangle. Okay, so the triangle's kicked out. So therefore, if I kick out, I have to kick out a negative with a negative. So this would have to be negatively charged if it goes in its place. So the square is negatively charged, means it kicks out the triangle. And that's what we call an anionic replacement. So basically, you're going to look at the thing that's by itself and see what charge it would form as an ion. So you'd look on your ion sheet, and if this piece that's by itself, meaning not with another element or compound, again, the thing that's by itself, the element that's by itself, meaning not with another element, just one element, only one capital letter, is by itself, would it form positive or negative ions? So I'm going to look this up, and I'm going to see if it forms positive or negative ions. If you notice here, this trades places with the circle. So they both would have to be positives, because positives can only kick out positives, negatives can only replace or kick out negatives. So I look at the thing that's by itself, notice no partner. So in an element form or in a formula form, you just see a single capital letter, a single atom. So the positive kicks out positives, therefore it's like, because the positives are trading, it's cationic. If the negatives are trading, it's anionic. Let's look at specific examples here. Okay, so I'm going to clear this and go through this with you again. So here we know sodium forms, let me switch my pen colors again. Sodium forms positive and iodine is a negative. Chlorine, notice it doesn't have a partner, it's just an element by itself. Yes, it's a diatomic, but it doesn't have a partner by itself, would form negatives. How do I know? I look at my ion sheet and I see that Cl would be a negative, not a positive. Down here, nickel is positive and SO4 is a negative piece, and magnesium by itself, so what's by itself? Magnesium. What would it form if it formed an ion? A positive. So what's kicking out what? The thing by itself is negative, so this would be a single replacement anionic. What's kicking out what? The positive is going to kick out the positive, so this would be a single replacement cationic. If you need to, rewind and listen to this again. Remember, what's alone does the kicking out. If it's negative, it's going to be anionic. What's alone doing the kicking out or attempting to? If it's positive, it'd be cationic. Double replacement is our next one. Notice there's going to be compounds on both compound plus compound going to compound plus compound. I like to say this is a do-si-do. So if you notice here, we have circle and triangle and heart and square, and then the backs switch places. So triangle and square traded partners, they do-si-doed. That's called a double replacement. You'll know it's a double replacement because you have two compounds on each side of the arrow. Here's an example. We have compound plus compound going to compound plus compound. So you would call this a double replacement. Notice I did not say if it was cationic or anionic. We do not specify that because that's not necessary because everybody's trading partners. So for double replacements, you'll just say double replacement. The only time you put single replacement, cationic or anionic, if it's single replacement. So you do not use the plus or minus except for single replacement. Again, you do not use the plus or minus except for single replacement. The last classification is combustion. How do you know it's a combustion? It has a hydrocarbon. A hydrocarbon is a hydrogen with a carbon plus an oxygen making CO2 and water. So if you have a hydrocarbon, something with hydrogen and carbon, there could be other things here, but if it has a hydrogen carbon piece that starts plus an oxygen going to CO2 and water, you'd classify that as a combustion. These are special synthesis and special decomps. We will not be dealing with them this year. Thank you. Please listen to as often as needed. Do not hesitate to reach out when you need some help.